Welcome back, students. In this section we are discussing about the scattering of light and some natural phenomena based on this scattering effect of light. What is mean by this scattering of light? When light travels through a particular transparent medium, the light rays interact with the fine particles present in that particular medium and get spreaded in that particular medium. This phenomenon is known as scattering of light. That means if you are considering the transparent medium as air, this air contains a large number of fine particles such as these air molecules, dust particles, water droplets and other minute materials. Whenever the light waves has to travel through this particular transparent medium, each and every rays of light or waves of light interact with the fine particles, and as a result of that interaction or collision with that particular particles, some of the light rays or some portions of these light waves get spreaded in that particular medium. That is known as the scattering phenomenon of light. When light interacts with the fine particles present in a particular medium, it gets spreaded in that medium. That is known as the scattering of light. The scattering of light mainly depends upon two factors. One is the size of particles present in that medium, and the other factor is the wavelength of that light. And how these factors are depends upon the amount of scattering that we have to observe. If we are considering the particle size, if the particle size is very small or a minute particles are considered, then the amount of scattering is very less. Very less amount of light rays are scattered or small portions of these light waves are scattered in that particular medium if the particles present in that medium is very minute one or very small particles are considered. As the particle size increases, the amount of scattering also increases. If that particular medium contains large sized particles, then the amount of scattering also increases. That means more amount of light rays or major portion of that light waves get scattered in that particular medium. That is a dependence of this particle size in the amount of scattering. And the second factor is the wavelength of light. Then if you consider a particular medium and the particle size, a fixed particle size we are considering, then the small wavelength colors or the shorter wavelength colors are always undergoes maximum amount of scattering or more amount of scattering. Shorter wavelength colors undergoes more amount of scattering or maximum amount of scattering. Whereas the higher wavelength colors are only undergoes very small amount of scattering or minimum amount of scattering. Shorter wavelength colors undergoes maximum amount of scattering, whereas the higher wavelength colors undergoes minimum amount of scattering. Shorter wavelength colors in a normal sunlight or in a white light we are considered as violet, indigo, blue. These three colors we can consider as the very short wavelength colors. And the yellow, orange and red, these three colors we can consider as the higher wavelength colors or with a more amount of wavelength. These are the two factors that depends upon the scattering phenomenon. One is the particle size and the other one is wavelength of that light. As the particle size increases, amount of scattering also increases. Then shorter wavelength colors undergoes more amount of scattering, whereas higher wavelength colors undergoes minimum amount of scattering. Okay. Then based on the scattering, how we can explain certain natural phenomena. Mainly two phenomena here we are considering. One is the explanation of blue color of normal sky, or in a daytime the sky is almost appears in a bluish color, and also the deep ocean surface also appears in a bluish color. And other phenomenon is during the morning time and in the evening time, that is during the sunrise and during the sunset, the sun and the nearby sky appears in reddish color. How these particular natural situations can be explained? Then, in order to explain these phenomena, we have to consider this scattering of light. First, we can consider the blue color of the sky. The normal daytime, the distance between the surface of earth and the sun is comparatively very less. So, the light rays has to travel a small distance through the atmosphere, and as a result, these light rays interact with the fine particles present in the atmospheric layers, then it undergoes scattering. In this situation, the shorter wavelength colors such as violet, indigo and blue undergoes more amount of scattering, and they are spreaded in that particular atmosphere. So, the combined effect of this violet, indigo and blue color results in a bluish nature of this atmosphere. The other higher wavelength colors are moved through the atmosphere without too much scattering, or very less amount of scattering takes place. So, only the scattering takes place for the shorter wavelength colors such as violet, indigo and blue, and they are get spreaded in that particular atmosphere. As a result of that one, the combined color appears as in a bluish nature. That is why the normal sky appears in bluish color. During the daytime, the sunlight has to travel a small distance through the atmosphere. As a result, the shorter wavelength colors such as violet, indigo and blue undergoes more amount of scattering and spreaded in the atmosphere, and the resultant color appears as in a bluish nature. The same explanation can be given for the blue color of this deep ocean surface or the deep water surface. The light rays from the sun, the remaining light rays which are not undergone the scattering, reaches through the surface of the earth, and this white light travels through the water body. Then what happens? The water also contains these water molecules, then other types of fine particles are present in this ocean water, and again the light rays undergoes the scattering. Here also the shorter wavelength colors like these violet, indigo and blue undergoes more amount of scattering, and they are get spreaded in the water. Then combined effect of that blue, indigo and violet results in the bluish nature. That is why this deep ocean surface or deep water surface appears in a bluish color. The scattering of light is the phenomenon behind this bluish color of sky, and the same scattering phenomenon is responsible for the bluish color of this deep ocean surface. At the same time, one point you have to keep in mind that in some situations, some water bodies or some ponds and other situations you can see in a greenish color. Here that greenish color is not a result of this particular scattering of light. The greenish color is only due to the presence of certain greenish algae. Don't be confused with this one. The greenish color of some water bodies are due to the presence of some greenish algae. Okay. Now next we have to explain how this sun and the nearby sky appears almost in a reddish nature during the sunrise and during the sunset, or in the morning time and in the evening time the sun and the nearby sky appears in reddish nature. Here also the same scattering phenomenon is responsible. During the morning and evening time, or during the sunrise and sunset, the light rays from the sun has to travel a long distance through the atmosphere. Before reaching to the observer, the light rays from the sun has to travel a long distance through the atmosphere during the morning time and during the evening time. As a result of this long path, what happens? Almost all the shorter wavelength colors are completely scattered out before reaching to the sight of observer. Due to the longer path during the morning time and in the evening time, almost all the shorter wavelength colors are completely scattered out before reaching to the sight of the observer. All the shorter wavelength colors like this violet, indigo, blue, green colors are completely scattered and they are spread in the atmosphere, but these atmospheric layers are out of the sight of observer. Then only the higher wavelength colors, the remaining higher wavelength colors travels through the atmosphere and reaches to the observer, such as is yellow, orange and red. The yellow, orange and red color has higher wavelength colors, and these higher wavelength colors are only reaches to the observer during this morning and evening time. As a result, during the morning and evening time, the sun and the nearby sky appears in reddish nature. The combined effect of this yellow, orange, red, this results in a reddish nature of the sun during the morning and evening time. Okay, once again keep in mind, during this morning and evening time, the sunlight has to travel a long distance through the atmosphere. As a result of that one, almost all the shorter wavelength, almost 100% of these shorter wavelength colors are completely scattered out before reaching to the sight of observer. So, for the observer, only the higher wavelength colors such as this yellow, orange and red can be visible. As a result of that one, during the morning and evening time, the sun and the nearby sky appears in reddish nature. Okay. Another situation you have to keep in mind is, normally the clouds are appears in white color. Normal sky appears in bluish color, but when it is in a clouded or clouds are formed, the sky or that clouds appears in a white color. And here also the same scattering phenomenon is responsible. What happens when the clouds are formed? What happens? The particle size increases, or the amount of particles are increased in that particular layers of atmosphere. As a result of that one, the amount of scattering increases. Particle size increases, as a result of that one, amount of scattering increases. That means almost all the wavelength undergoes scattering. It's violet, indigo, blue, green, yellow, orange and red. All the 7 colors are completely scattered when it is passing through that particular cloud. What happens if all the 7 colors are spreaded in that particular medium? That appears in white color. Already Sir Isaac Newton, it is verified that when 7 colors are combined together, then it forms a white color. Okay, or white light is available. So, all the 7 colors are get scattered when it is passing through these clouds. Then as a result of that one, the clouds are appears in white color. Okay. Then one more application level situation you have to keep in mind, that if an observer is in out of this atmosphere of this earth, that means an astronaut or a space traveler who is outside the atmosphere of this earth can only visualize the earth or surrounding sky as in a dark color. Why it is appears in dark color? The reason behind this one is, in the outer space there is no medium. Due to this one, the light rays from any source does not undergoes even the reflection phenomenon, refraction phenomenon or the scattering phenomenon. That means the light rays passing through that particular region does not undergoes any kind of these phenomenons. So, nothing can be visualized in that particular region. That is why that regions are appears in dark color. In order to visualize a particular material or a matter, any of the phenomenon of light has to be taken place. Sometimes it may be a reflection phenomenon or refraction phenomenon, or even the scattering of light has to be taken place. If there is no matter, any of this phenomenon does not take place, and therefore that region only appears as in a dark color or dark in nature. Okay. That is why for an outer space traveler, the surrounding is appears in dark color.